Introduction to Integration. Made easy. Let's start with some basic math principles. What are some of the opposite operations we know? Well, we know about addition and subtraction, multiplication and division. We've also learned about derivatives. Well, the opposite of a derivative is an integral. Here, we are looking at this equation, which symbolizes the opposite nature of integrals and derivatives. We can see that taking the integral of a derivative will yield the original function. In this next equation, we see that taking the derivative of an integral will yield the original function. Therefore, integration is the inverse of differentiation, and differentiation is the inverse of integration. Let's go over some terminology. F of x is called the integrand, which represents the term that is inside the integral. Dx is our variable of integration, and c is our constant of integration. Derivative versus integral formulas. Here is a table showing a few formulas for derivatives and integrals. We can see similar and opposite natures between the two operations. Let's look at the first row. We can see that the derivative of a constant is 0, and the integral of 0 is a constant, meaning they are opposites. Let's skip down to the fourth and fifth rows. Memorizing formulas can be difficult. However, if you are able to remember the derivative formula, then you know the opposite is the integral formula, shown here in these rows. Let's go over some examples. Example number 1. We want to find the integral of 3x dx. What we can do is use the constant multiple rule, which means we can take the constant and bring it to the front. What that's going to look like is 3 integral x dx. From here, we're going to use the power rule. I'll show the power rule here on the screen. All we do is we add 1 to the exponent. So, our problem right now is just an x. The exponent is 1 already, and all we do is we add 1 to it. This number here, when you add, is going to be in the denominator as well. So this will be also 1 plus 1. So our integral will become 3 times x squared over 2. And whenever we take an integral, we got to remember the constant of integration, which is c. So we're going to add plus c. From here, all we have to do is distribute 3. What we'll end up getting is 3 x squared over 2 plus. Now, remember that the c is just a constant, and we're going to multiply another constant to it. That means that 3 times c is still just a c. This is going to be our final answer. Example number 2. We have the integral of 3x to the fourth minus 5x squared. Looking at this principle here, we can separate these terms and do the integration separately whenever they are being added or subtracted by each other. Let's go ahead and start by rewriting this. What we'll have is the integral of 3x to the fourth dx minus the integral of 5x squared dx. Now we can go ahead and use the constant multiple rule, where we can pull out the constants to the front. Doing that, what we'll have is 3 integral x to the fourth dx minus 5 integral x squared dx. From here, we can go ahead and use our power rule. Let's start with the first term. We have 3 times x to the 4 plus 1. All we do is add 1 to the exponent, and then that number is also going to be on the denominator. And then we also have to include our constant of integration. In this case, I'm going to label it c1 since it's our first term. Now, working out the second term, we have minus 5 times x to the 2 plus 1 over 2 plus 1. And we're also going to add a constant here, and I'm going to label it C2. Let's go ahead and simplify. What we'll have is 3x to the 5th over 5 plus 3 times a constant is still going to be our constant, so we're just going to go ahead and put plus C1 here. Simplifying the second term, we'll have minus 5x to the 3rd over 3. And now, same kind of concept applies. We'll go ahead and put negative C2 here. Last thing we want to note is that C1 minus C2 is still going to be a constant. We're just going to label that C. All we need to do is include one constant term. Now what we'll get is 3x to the 5th over 5 minus 5x to the 3rd over 3 plus C. So 3x to the 5th over 5 minus 5x to the 3rd over 3 plus C is our final answer.